Okay, so this was originally going to be a panel with more representation, but due to travel restrictions and various other problems, it's down to 2 people. But we're still going to try to make this interesting, I think, and talk about this, even though there's a Juniper slant on this. We're really going to try and talk about scripting on routers as a general technology, what you can do with it, how you can improve your network with it. And the same concepts apply to any vendor, whether it's Juniper or not. So I'm going to have Phil Schaefer start.
Hi, I'm Phil Schaefer. I do the Junos software, CLI, network management software for Juniper Networks. So I'm going to start with a description of the problem we're trying to solve. It's a problem of complexity. The router configuration is getting more complex. At the same time, the cost of failure is getting higher, and at the same time, more people are trying to touch devices in your network. Depending on your study, 50 to 70% of errors are human errors, configuration errors. So trying to find ways to address that is a win. The typical network management answer is a top-down design where your database of record lives on a central server. You generate configs from that and push them to the device. This is a great model, but we don't seem to be able to tear people away from the CLI. So what we try and do is give them tools, put tools on the device to allow you to get some of the benefits of configuration, of automation and scripting on the device. What we're trying to do is to provide tighter integration between what you're trying to do with your devices and the device, getting the device to be a more participant in your policy decisions, allowing you to talk more in high-level concepts, and for that to filter down into impacts on the box. What we want you to do is to be able to write a script that takes your policy, encodes it, you test it, you deploy it, and from that point on, your policy can't be broken. You have faith that configuration changes on your box are going to follow that policy. I'm going to back up a bit and talk about the XML API that we provide. It's standardized as RFC 4741. It's a real simple RPC. You send XML data, you get XML data. There's a mapping between CLI commands and the RPCs, and you can see at the bottom of this page the command line and the RPC that it's encoded as. The command becomes an RPC tag, and the arguments are encoded inside that RPC as XML elements. Once the RPC gets onto the box, the on-box software passes it around inside the box. It's given to the appropriate system subcomponent. The system subcomponent generates XML data back to MGD. MGD either passes that to the CLI user where it's rendered into text, or it passes it back directly to the API client. So the big win is that the data you're getting is the data that we're using internally. And here's the output of the show route command. You're looking at the rendered content in the upper panel and the raw XML in the lower panel. And that XML to text rendering is happening at the CLI. So we have 3 scripting technologies. We have commit scripts that are part of the config process that allow you to introduce constraints into how your configuration can behave. There are op scripts which add new commands to the CLI, and there are event scripts which are triggered when an event happens on the box and allow for an automatic reaction. For commit scripts, what's happening is at commit time, your configuration is generated as XML. It's passed to your script. Your script is written in a language called XSLT, or XSLT is the W3C standard for XML to XML transformation. So you're getting XML in, that is the configuration, and you're generating actions on output in XML form, and those actions are then evaluated and performed by the management daemon. So the kind of constraints you can do are you can have tests that require configuration to appear, or require configuration not to appear, or require interrelation between configuration. You can say if I'm configuring LDP, I have to configure IGP and vice versa. I can say I don't want to consume more physical resources on a PIC than 1,000 PVCs. I can say, you know, all my policies should look like this. And when they fail, I can get a commit error that looks just like every other commit error coming out of Junos. In this case, I'm missing a LDP configuration for a particular interface. In addition, I can take that rule that says, you know, my IGP and LDP have to be co-constrained, and give myself a get out of jail free card from the start. I can say, I'm only enforcing this rule if you don't tell me not to. Here's a apply macro statement that says don't configure LDP for this OSPF area. Apply macro is a statement that can appear anywhere in the Junos configuration. It takes a name argument and can contain name value pairs. The contents of it are completely up to the user. It's carried along as Junos configuration, but we don't do anything with it. It's a place where you can put data for commit scripts. So a commit script can change the configuration. It emits a change tag with content telling it what part of the configuration can change. So I can, in addition to constraining the configuration, I can repair the configuration. If you're missing the LDP configuration, I can generate it for you. I can take any rule and make it implicit, and I can give you a syslog message or a warning message as I generate that, as the script generates the new configuration. There's also a thing called transient configuration, where configuration is passed to the software on the box, but does not reside in the candidate or the committed configuration database itself. So I can make implicit rules in my configuration. I can take my LDP configuration and say, well, it's entirely based on my IGP configuration, so I'll just automatically generate it. The entire source of error is removed, and the configuration is more error-free. So we'll walk through an example. This example is a co-constraint between ISO and MPLS. The rules are if an interface has family ISO configured but not MPLS, then I'll add MPLS to it. If the interface is not configured under protocols MPLS, then I'll add it there. I use a helper template, which in XSLT works like a function called JCS emit change, and I'll generate warnings for both of these. So before I have a configuration with family ISO, as I commit, I'll get error message saying what the script is doing, and then afterwards I'll have the MPLS configured for that interface, and also that interface configured under protocols MPLS. So how does it work? In XSLT, there's XSLT uses a standard called XPath, and that's a means of finding nodes inside an XML document. So we'll have an example of that on the next slide. The emit change function takes 4 arguments. Content saying what change I want to make. $. Tells me where it is relative to the configuration. $message is a warning message to display, and $tag is either change or transient change depending on the type of change I'm making. It defaults to change. So your script will generate those as actions. They're passed back to MGD, and MGD looks for errors, and if there are no errors, allows a normal commit. There's a nice one-to-one mapping between interfaces, between the configuration as expressed in Junos and the XML equivalent configuration, and so we can generate that easily. If you take a XML configuration and think of it as a tree, there's a standard called XPath, which allows you to find things in that tree. So in this example, it's looking for interface unit nodes, and then in the square brackets it has what they call predicate expressions, which are Boolean expressions. In this case, it's testing for the existence of the family and the ISO tag. So this will select the unit pointed to by the arrow, because it matches the path and it satisfies the predicate. So here's the script. We use an alternative syntax for XSLT called slacks. The script starts by matching on the configuration tag, It pulls into a local variable a reference to the protocol's MPLS statement, and then for every unit that matches the XPath from the previous slide, if there is no MPLS, if MPLS is not configured, it sets a variable called message, this variable called content, to add the family MPLS statement, and then it calls emit change, which will do the work of actually emitting the XML. If the interface is not configured under protocol's MPLS, then it will again declare a message. The content is going to change, and the content. And most commit scripts look like this. There's a for each saying for everything in my configuration that looks like this, and then an XPath for the expression that you want to test, and then either the error or the content that you want to generate from there. So we talked about the apply macro statement. I can take that apply macro statement and pack into it a more dense, high-level view of what my configuration is, and then I can have a commit script generate from that high-level view the low-level configuration bits and spread them wherever appropriate throughout the configuration. So here's an example of an interface configuration that simply says what the IGP and area and class are, and the interface protocol, class of service, RPM, any statement I want to generate based on that configuration I can. So moving to op scripts. Op scripts allow you to add commands to Genos. It's the same driver, it's the same mechanism. Op scripts don't get configuration as input, but they can perform any XML RPC and get the results. So they can do the get route information, the get interface information RPC, get the information back, use XPath to inspect the results that they got, and then perform interesting things with it. Op scripts are used for three things. They're used to get better information off of a device. They're used for diagnosing problems. They're also used for standard operating procedures. If you have a mechanism to add a customer, if you have a standard operating procedure to add a customer, to add a BGP peer, you can put that into a script. The script can ensure that it's performed exactly the same way every time, and after deploying the service, can also test the service and make sure everything's working correctly. You can also use scripts to find violation of your policies, to go throughout your network and look for issues, find them before they bite you. So op scripts work by adding, we've added the op command. The op command takes a script name and then a set of name value pairs. And the name value pairs are actually described in either the configuration for the script or in the script itself. So the argument provided here, the pure argument, is what was given as completion on the previous slide. And they can appear directly in the script themselves. This script takes an interface and a protocol and then declares those as XSLT parameters with the default value for the interface as being FXP0. So here's an example, a dead peer script. It goes through, you can either provide it with a peer or it will do a BGP peer summary information, RPC, get back the result, look for every peer that's in the connect state, which is the state that a BGP returns to when a connection fails. It will call dead peer for that state. Whoops, wrong direction. The dead peer template does a get BGP neighbor information, looks at the state that's returned, reports the error, the last error, the last state, and then it performs more operations than I can fit on a slide, but it can go out and look at the next hop, make sure there's a route to the next hop, look for the outgoing interface, make sure it's up, look at the error counts. It can do a sleep and refresh the error counts to see if they're increasing. It can do pings to make sure the next hop's reachable. It can go look through the syslog to find the reasons why it failed, when it was last up, all that sort of stuff. In addition, you can perform remote RPCs. NetConf is supported over SSH, and our box can do SSH, so you can contact another router, do an RPC to that router, and get information from that. Most network problems are not isolated to a single node, so being able to get information from both nodes gives you a better chance of diagnosing the problem. In addition, if you're doing an op script, standard operating procedure, if I want to add a BGP, add a peer to my BGP mesh, I can go to a peer that's already there, download its list of peers, and then contact each peer in sequence and add my side and the remote side to the configuration. Here's an example script that does an intelligent trace route. It logs into each hop along the way, reports what the device is, what software it's running, reports the outgoing interface, how that route was learned, reports latency issues for the particular link as opposed to the full path. In addition, you have the ability to do interactive scripts. You can prompt with either your keystrokes being echoed or not echoed. On top of that facility, we've built a wizard framework where you can describe in metadata what questions you want to ask and what the logic to drive those questions are. You call a wizard function and it runs the whole wizard for you, and you get back configuration that you can be then loaded onto a single box or onto multiple boxes. So I can make a tunnel script that asks you for the remote peer, goes to the remote peer, pulls back a list of the available tunneling interfaces, tells you the number of tunnels currently configured, how much bandwidth is being consumed by those tunnels, help guide you through making the proper decision. It can then deploy configuration on both ends of the device and then test to make sure the tunnel's up and working. So you kind of get the benefits of having the traditional external generated network management view without having to go to the network management box. You can sit on one box and say, I want this to happen on my network, and get it to happen. So event scripts. We went through our source code and replaced syslog calls with event daemon calls that allow us to get better information out of the software. So you can take those events, run them through if-then rules that can dictate actions. Those actions can either be individual events or certain events occurring within a particular amount of time. And one of the actions you can do, you can compare attributes for particular events, saying if the interface address of this event matches the address of this event, then I want to perform the action. Here's a simple event policy that retrieves information when a SNP link up or down is seen. You can also do time-based configuration, mimicking cron, do time of day or interval timers. You generate an event and then you attach that event to a script or an event policy. So this is a script that we used to catch a particular piece of hardware that was failing. And while this script ran in the customer network, we would catch the problem, reset the PIC, and it gave us a means of recovering while the problem was being diagnosed and the part was found and the microcode was fixed. So this particular script does a couple of regular expressions to pull out the FPC PIC and PFE, and then simply issues a offline request for that PIC, and then waits 15 seconds and brings it back up. There's also a mechanism of dampening changes. So if you have a script that you want to run a particular number of times, or that you want to restrict so it doesn't run too often. You have an event policy to reset a PIC, but you don't want it to go. You don't want it to occur too often. You can use the JCS dampen function to guarantee that. There are also hooks to allow you to set MIB variables and generate traps. In addition, you can record data in accounting profiles so that accounting profiles basically give you a log of data when you cross a size or time threshold. That data is compressed and shipped off the box. So there's more information available at these URLs, and that's it.
So what I wanted to do is go through and find the most interesting scripts and give examples. So just quick recap. What do we talk about? Scripting and routers, pretty much what Phil was talking about. I mean, really, why we need scripting on routers? Everyone says, well, the perfect solution is this magical box somewhere, this database that knows the perfect state of your network and does all the configuration, and you never have to log into a router. And the reality is, unless you have either a very constrained network and a lot of discipline, you're not really able to implement that. You're going to restrict what you can configure. You're going to have one-offs. They're going to happen. So by using scripting on the routers, you still get the benefits of automation. You still get 99% or whatever percent you can automate covered, and yet you can still log into the router and make a manual change. You're not completely dependent on the database having predicted every possible outcome. The reality is humans make a lot of mistakes. Humans cost a lot of money to maintain. And anything that you can automate, it just makes the network run better and run cheaper. So yeah, what I was saying about you can use expect Perl scripts, you can do screen scraping, you can do netconf, but there's a lot of benefit to running things directly on the router. So the three examples that I picked to document were I thought the three most interesting scripts that I've written that are common problems people run across. The first one is how to do your BGP policy. Anyone that has a complex BGP community system knows how difficult it is to maintain. It's a lot of lines of code, and if you want to implement per ASN communities, there's networks will do it for their top 10 biggest peers, that kind of thing. But there's very few people who will put the human time into doing this for every network. And if you automate this, you can support BGP communities for every peer that you have, even if you have hundreds of peers. The next one is prefix list management. Auto-tuning prefix limits through the script, and then the third one is gathering support data for opening cases. So here's the details of the automated BGP policy. So what I start by doing is defining a BGP location. This is the BGP communities that I'm using. I'm defining for the router. I'm saying this router is in this city, this continent, and this region. And I stick that under the system level. That applies to the entire router. And this is through the apply macro. It lets you set a custom configuration option that might not ship with the router, but that your script can then take a look at and build from. So then, for example, I configure an example peer. I don't have to do anything complicated. I just configure the neighbor, the description, the peer AS, and everything pretty much gets built from there. So you commit the configuration, and the commit script runs. So the first thing it does is it reads in the location data from our things, and it does a for. It runs through the config, and it runs this function against every configured neighbor. So it starts by, here's an example of how it generates the BGP policies themselves. So it's generating the policy statement. It's matching from the certain community. It's doing the action, and it's way too long to fit in this paste. But you go through your policy, and it will auto-generate this. Here's how it's generating the BGP communities itself. So it builds the regular expression from all the configured elements here, and then it goes through and generates the actual communities themselves. So it's going to build actions. In this case, I have it do 1 through 4 prepends. I have an action for set BGP med to 0 on export. I have an action for deny export, and then I have an action for override. If I had previously denied it, like if I had said no export to peers, then I could say accept this peer. And also, the script builds the generic community tags for the router, so you don't have to go maintain for every router, for every configuration. You don't have to go manually maintain the tags that you will apply. The script takes care of it. So these get referenced in other policies, but your router will automatically always tag your routes correctly. And here's an example of, kind of the output that it will build. And obviously these are greatly truncated because it'll build a lot of output automatically for every configured neighbor. And then the other cool thing that I did in the same policy is build AS path leak filters. So what I did was define a list of ASNs that I wanted to hear directly. If I didn't connect to them directly, I would hear them through a transit, but never through a peer, never through a customer. And the only way to do that, it turns out, you can't actually, there's no regular expression command to do everything except the neighbor that I'm connected with. So the only way to do this is to do it in script where you generate an AS path filter for every peer, and you basically put the entire list except the neighbor. So in this example, if I peer directly with AS 701, I'm going to build a filter so that for any neighbor other than 701, I'm not going to accept anything with 701 in the path. And it turns out this is a really effective way of preventing leaks because people end up leaking the full routing table. They leak your major peers, and it's not only good for preventing leaks, but it's good for protecting your customers because even if someone doesn't leak a huge number of routes, even if it's small enough that it may not hit your prefix limit, you're not going to be hauling 10 gigs of traffic through someone's DS3. So it's very good to do that, and this is the kind of thing that you can really only realistically implement in script. So I do it at the same time in the same policy. It's also useful for building a policy framework. So for example, when someone configures a neighbor on our routers, you don't have to go change the policy chain. You don't have to go tweak the details. What will happen is the script will scan for a policy name with a standard naming convention. So if I create a policy called policy-AS3356-N, it's automatically going to link that in. And the benefit of that is you provide protection. You can write ways that even if someone in your NOC who is supposed to go in and change a local pref ends up misconfiguring something, they can't leak the route. So you greatly protect your network against human errors while still giving people flexibility, and it's all policed by the same policy at the same time that it goes to link this in. And I think it simplifies the BGP policy, the configs. It really makes things a lot easier to maintain. So here's an example of how it links into the policy. So it just inserts itself into the policy chain, inserts the Aldo community stuff, and then later it inserts the AS filters, and then later it inserts the policy links if those exist. And once you write this code, you only need a few people to write this code, and then all of a sudden your network can maintain itself. You don't need as much distributed clue through your entire network at all times to prevent errors. So the benefits of this, this script automatically generates and maintains 44 lines for every BGP peer that you wouldn't have to go write yourself manually, and it's pretty complex regex code. And that's actually just the policy. That's not the AS filter. That's probably another 50, 60 lines. So it really creates a good effect where you might have hundreds of BGP peers, and your config is greatly reduced. And you can support things like per ASN communities and leak filters and whatnot. The other one that I did was an op script. This is automated BGP prefix list management. So today operators use prefix limits for safety nets. If we configure a peer that we expect to send 5,000 routes, we might configure a policy that says up to 10,000. And if they send more than 10,000, we're going to drop the session because something's wrong. It's a workaround around not having good filters, but it's pretty effective. The problem is it's pretty difficult to maintain. Networks change over time. They grow, they shrink, they add customers. And if you only touch your prefix limits when they break, they're going to break a lot. So you might have a peer that you haven't touched in a year that has 8 sessions, and then all of a sudden, over the course of a year growth, it hits your limit, you trip, and you're down. And there's probably more outages caused by those collectively than there are prevented by prefix limits in the first place. So what I did was write a script that maintains this on the router itself. And it tries to do a good job of keeping the limits at a sensible value. And in reality, it actually helps keep the limits stricter because you don't have to leave a year's worth of headroom. You can have the script run every night. So I said, how do you determine a sensible prefix limit? I start by looking at the number of current prefixes. you want to add some percentage for growth, and then you want to add some fixed number. So if someone sends you 2 prefixes, your limit's not going to be 3. It's going to be reasonable. But if someone sends you 5,000, your limit's probably going to be 7,500, something like that. But you also don't want to react to changes too quickly. You don't want the script to run one night and the network happens to be doing a maintenance or having a problem, and they're announcing a low number of prefixes, and so all of a sudden your limit changes and they come back to normal and you break them. So what I did was use a weighted moving average. So over the course of time, as the network changes its number of routes, the script will react to that. There's an example of the script that does it, and I mean it's really pretty simple. You go through your BGP neighbors, and you run your BGP summary information. You look at your neighbors, you walk the list, and you say, here's the number of routes that we're currently receiving from them if the neighbor's up and working. And then we do our calculation. We say, times 1.25 plus 500, and then I've kind of rounded off in groups of 500 because I don't want to make unnecessary changes. And what happens is it runs nightly through an event script, and it takes care of itself. And we've been running this for about 2 years. And it really does a great job of maintaining the network. And you could do some of this with offline scripting. You could do this with things that screen scrape, or you could do this with netconf. But it turns out to work really well when it's right on the router. So here's another example of automating support cases. We all find bugs from time to time, and we need to gather information. But it can be a pain to gather all the things that they want, put it all together in a file, and upload it. For a vendor that supports uploading data via FTP, it's made a script for it. So it goes out and gathers the log files, and not just the standard ones, but it goes and grabs the support information. It goes and grabs things from both routing engines, things like that. So you're getting a complete view. So here's an example of setting where I'm uploading it to, and if I ever need to change it to point somewhere else, I can. I gather the support information, I gather the configuration, I gather the messages, the chassis, and there's any number of other files that you can gather at the same time. You can gather PFE information. You can log into the FPCs of the box and gather really detailed debugging. Create some temp files to upload all these things, and it does a copy upload. How effective is it? If you look at an example of a random router, the configurations versus what happens after you expand the commit scripts, 62% reduction in size. And not only does that make it easier for you to maintain, it's less when your NOC people are looking at this, or when people who are not routing gods look at your configuration. It's a lot easier for them to follow what's going on. So it reduces errors. It makes things better for everyone. It's a really great technology, and I think more people should use it. And that's about what I got. So questions?
Hi, Aaron Hughes. First, thanks for this presentation. This is absolutely awesome. Love to see more automation. A plug for PeeringDB. An alternate method would be to select the number of max prefixes from PeeringDB itself, rather than checking the state and continuing to increase. That way the peers can manage their number of prefixes. Secondly, I have kind of a question for the room. I do a lot of automation scripting with routers, and the few people that I've talked to that do it certainly have a significant problem with normalizing data on getting configs, particularly with version changes and line wrappings and moving to V6, for example, not having enough characters in the row. Mm-hmm. And it's significantly painful. But once you get past that, even still, and if you build a solution that's nice for generating configs, I find that companies are still afraid to implement them. And I'm not sure what the underlying fear is. But I talk to a lot of companies in this room where there's concerns about handing it off to a script. And hopefully some of the audience can talk to why.
Well, so to your first point, I actually think there's a way that you could have the scripts go out, make a call, load data from an external URL, and then use that to populate things. So that's actually completely implementable solution is to go query peering DB and figure out what the peer thinks they should be sending you. As far as fear of automation, I have to assume people have been watching too many Terminator movies and they're afraid the machines are going to rise up against them.
Well, that's what I wanted to comment about is yes, humans make mistakes, but humans tend to make mistakes slowly. Scripts can make mistakes very, very quickly, like on your entire network within a few minutes.
So that's an example.
So it's just good lab testing, and I think that's the fear. Like if I need to make kind of an emergency change to the network, and I'm doing it manually. Well, I might be able to screw it up, but it probably won't screw it up too bad. But if I need to crank out a script really fast to change a whole bunch of things in the network really fast, I could screw up the whole thing really well quickly. So.
I agree, and that's really where I've seen the biggest problems with use of automation. Is an example, I go and make a change and I think, oh, this is simple, I as a human make this thing and I want to send it out to, every router in the network. Enter. Whoops, that wasn't the right thing to deploy. Now you've completely screwed your network. I think it's different when you're talking about designing scripts because you're not, in the heat of the moment writing a config and then blasting it out. That's a different problem than taking time to design a system that provides error checking, that provides a robust structure. And in that case, even though it's automated everywhere, you're providing better controls, I think. Yeah.
The other thing is, while you're making that change, you can, if you're doing a script, you can go through the pain of doing a confirm commit, so that you have to do a follow-up commit and making it automatically correct itself if it becomes unreachable. So if it's a disaster, you can automatically recover from it.
So actually, I think I'm going to taper into this. Jared Moss with NTT America. One of the things that we've found to be very problematic is that some vendors don't, for example, have a commit or rollback in their portfolio. They may have one specific product line that has that, but in the past 10 years, they haven't had the opportunity to look down the road and identify something that's important for those of us who need to automate our networks in order to save on some of the OpEx of having hundreds of thousands of humans running around in the network. And I'd like to say that I think that this is something that's very important that we all need to make sure that we're asking for and explaining to them very clearly that they are losing business as a result of not having this functionality in their equipment.
Am I to understand that it's not acceptable to just not write mem and then reload the box if it doesn't work? Because that's what they tell me.
Actually, in our network, on those devices, we don't type write mem. So, yeah, we go and we actually take a machine-generated config and put it into startup configuration. So we've actually detected bugs in their config parsers where it actually processes in a different mode depending on if it's in the startup config, and it's in startup config parsing mode versus actual like interpretive parsing mode as well. They have two different modes, which is very interesting to me.
Yep.
One last request, Raz. On your next version of IRPT, it sure would be nice to have scripts like this that come with it so we can actually distribute these filters in an easy manner, and hopefully we can get more customer prefix filtering.
Definitely. Actually, I could have sworn I had an example, but for something like this, there's two approaches you could take. There's the approach of pushing the configs to the router, which is really a netconf type system, and that's IETF standardized. In theory, there's other vendors that support it. I'm not sure if they actually support it, but you could potentially write a script that goes out and pulls this data down. It's possible. It's a question of how often that data changes when you might want to evaluate that. But yeah, I could see putting together some type of script that like gives you an option where you go refresh on the router and it pulls down all the new data. That's viable.
So, sorry, in the back corner. This is Chris.
There's a light blinding me.
Oh yeah, well just look over this way. So the automation stuff on routers, I think people get most worried about the, I broke the entire network, right? Having watched somebody break an entire tier 1, well, say tier 1 backbone with a script that does ACL stuff.
Let me guess, they forgot the permit at the end?
I don't know. I just heard the guy on the phone, like I heard all the other phones in there not go off, and then I heard the other guy go, "Oh shit, it's breaking the network, turn it off."
I've heard that at least 5 times.
Right. So that sort of thing, and again, but that's a tactical. You know, I wrote something tactically, or I did something tactically. It's not well planned. Anything that's well planned and you know that you have stock configs for, doing it in automated fashion saves you people time. It saves you OpEx. There's no sense not doing it that way. So,
I agree.
thanks for the presentation, by the way.
Leo Bicknell, ISC. Just to touch on the question of why more companies don't do this, I'd offer up 2 reasons that I've seen at a number of companies. First, an awful lot of ISPs have people they call coders. I wouldn't run their code anywhere on any platform because it looks like spaghetti mess. I think our industry as a whole has a lack of competent programming talent backing up our automation systems, our scripts on the routers, everything. I think companies just don't invest in enough good coders. I think in this particular case, you actually have a double problem. Any coder that writes something has to have some decent understanding of the process they're coding. And the intersection of people who are both good coders and have a deep enough understanding of how routers work that they know to write code is a very small subset of people. And the guys who are doing it are doing great stuff, as we see in the presentation. But I'm afraid that probably 75% of the companies in the room lack the intersection of somebody with the knowledge of how a router works and good enough coding skills to simply write the scripts. And more training in coding for routers, I'm not sure in quite what venue, would probably be a really good thing.
Yep, I agree with that. You know, it seems that anyone that is good at writing code works for a vendor. And the people that are actually running networks that really have an understanding of what the problem is, there's a very limited base. So I think there was a URL in Phil's presentation for a repository of stuff. I know I have a repository of all these things. I forgot to include the URL, but it's for these particular scripts. It's on juniper.clupon.net, which is a wiki that maintains a bunch of things. But I would really like to see, you know, that's why I wanted to put this together, is to see more discussion, more people talking about ideas. Because, I mean, really, the language itself is endless. So if we can get more people putting together more good ideas, coming up with more code to share with everyone, I think we could, you know, really improve things. Randy?
Randy Bush, IJ again. It's not a coder. What you want is a software engineer. And I can teach a software engineer what they need to know about networking. I can't teach a networker what they need to know about software engineering.
True. Anybody else? All right. Well, thank you all.